one is down.
Oh. Okay, so I will start with number 3.
Yay.
While you are, oh, hold on. Which hypothesis involves equality? I got the null hypothesis.
It's the null, right?
Yeah.
I agree.
Okay.
I got the same.
Okay, perfect.
Aye. Yay. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually. Okay, so remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
So I put alternative because when I was reading about them, it says, hold on.
Go ahead, is this the confusing part? Because we're supposed to assume that the null is the status quo.
Yes.
Right.
And then right after that it says
Okay.
is typically considered appropriate. Hold on, where did I find?
No, you're fine. Let's look it up. Go ahead, Michael.
Hold on, I have the book thing open.
Oh, perfect, perfect. It's a trick.
Emily, it's in a box. And it says pro air. It should be on the counter by the dishes. The dirty side where the. Sorry, thank you.
So,
Okay, in contrast to the null hypothesis, we write the alternative hypothesis. This is typically the statement that a researcher suspects is the actual truth. So, and then in the question 4 it says, at least as extreme as one that was actually observed.
okay.
So,
What do you think?
actually, so to me, I don't know, it meant like actually observed is the same as being researched. I might be wrong though.
Well, we can always do it again. If we just have to choose between the two, it's not like it's,
Yeah.
I don't know. But because it says when computing the p-value. It's just these kind of questions that I don't like. So we're going to go with alternative?
Either one.
Go ahead.
Either one.
All right. You want to do one more D?
Yeah, hold on.
You're fine.
I'm trying to find it because I thought it was the alternative as well.
Okay.
Because
Well,
there's a part in it.
Go ahead.
I don't know. Like you said, if we get it wrong, we get it. I mean, we can always change it. It's only 2 at least. It's not 4.
Well, this says we never prove a null hypothesis is true. We only gather evidence against it. If we get enough, we reject.
Hey, hold on. So this one right here says when we test our hypothesis, we assume the null hypothesis is true. So would it be the null hypothesis? Because this one, we put which hypothesis do you assume to be true?
Yeah.
Okay. Well, I'm gonna go with null then, because if it's wrong, there's one other answer, and I can go back and change it.
Right. I'll put null too, because that's what I might. Anyway. All right.
Okay. Number 5.
Suppose the null hypothesis is sorry, 8-0, the mean is 10. Use this information to answer the next 3 questions. Question 5, which of the following represents the alternative hypothesis for a 2-tailed test?
I got C,
Okay.
the one where it's not equal to.
Yes.
Okay.
A two-tailed, two-sided, yeah, not equal, you are right. I
Yes.
have been.
Number 6, which of the following represents the alternative hypothesis for the left-tailed test? I got A.
Left-tailed
Yes.
is, yes, I agree.
Yes.
Okay.
Speak up, Michael, if you disagree. Okay, which of the following represents the alternative hypothesis for right-tailed?
So that one I got.
Two. Do you agree?
Yes.
Agree? Okay. Question 8.
Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance or the symbol. Use this information to answer the next 2 questions. Which relationship would result in failing to reject the null hypothesis?
Okay, I have my notes. So if if the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than alpha, we fail to reject. So if we want to reject if failing, then p-value needs to be greater. If we fail to reject, p-value needs to be greater than alpha. Let me try that one more time. If p-value is greater than alpha, we fail to reject the null hypothesis. Sorry.
If the p-value is greater, we fail to reject it.
That's what my notes
Yes.
say. P-value
Yes.
is greater
Okay.
than we fail to
So
reject.
it would be A.
Yeah.
Yes, because it,
Okay, and then 9 then would be B, right? Because it's just the opposite.
If p-value is less than alpha, we reject.
correct.
Okay. Okay, number 10. Which of the
Wait a minute.
following...
Did I lose you?
To determine if the p-value is small enough. Okay.
Yeah, it was B?
Yeah.
Okay.
Mhm.
Okay, number 10. Which of the following would be the appropriate alternative hypothesis, HA?
Okay, so
So this is the part that I didn't understand.
saying that the average claim is $1,500. They're concerned that the true mean is actually higher. So they think that the mean is actually higher than the $1,500
Mm-hmm.
information. So which of the following would be appropriate alternative hypothesis? So what that means is that the average greater than 1,500 is nice.
Mm-hmm.
They think that the average claim is actually higher. So they think it's actually
Okay.
higher. So the alternative is that the average claim is higher than $1,500.
Okay. Oh,
Thinking C.
okay. Yeah. That makes sense.
So it's all about reading the words and understanding them.
Mm-hmm.
All right.
So would 11 then be D? The average claim amount is less than 1,500?
No. Which of the following would be the appropriate null? Remember, it's got to be an equal. So the null hypothesis is that it's equal to 1,500 because that is so the average claim is equal.
Oh, okay.
So the null has to be equal, and then the alternative can be not equal or less than or greater than.
Okay. Okay.
Please push back because
No, you're right.
I'm like,
Because,
it hurts my brain.
no, because like you said, oh my gosh. Can't handle another day of this being sick. I'm going back to the null hypothesis.
It should represent equal. That was another question. All right.
No, that makes sense because the null hypothesis it has to be equal to.
Right.
Okay. All right, we ready for number 12?
Yes, I'll read 12.
I am.
The insurance company randomly selects n equals 40 claims and calculates a sample mean of 1650. Use this information to answer the next 3 questions. Question 12. The insurance company assumes the distribution of the sample mean is normal. Is this an assumption?
What's our sample size? Yes, because our
Yes,
sample
40.
is large.
Yeah.
So it's a good sample since the sample size is large. Sorry.
So, and that, what theorem or law justifies your answer to the previous question?
That's the central limit theory.
Yeah.
Okay.
Okay, and which of the following is a test statistic as defined in this lesson? I got Z.
Yep. Z.
Yes.
The historical mean of sales receipt at a grocery store is $150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. So the null is equal to 150, and she thinks it's lower. So she thinks the new population mean should be less. She will use the level of significance of alpha at 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes a mean 144. Amount. So we've got our sample mean is 144, our population is 150. And what was our deviation? Did they give us the standard deviation?
The
$40.
40.
Okay. So and our sample size is 36.
Mm-hmm.
So we're going to solve for Z-score, right?
Yes.
So 144 minus, sorry, I'll keep I'm so noisy. Okay.
Okay.
Okay, so we got to take 40.
Oh,
Wow. All right. I get a -1.
Hold on. -6. Okay, I'm getting -1.2. But
Okay. Let's do it again then. I can do it.
hold on,
and Michael got -1.5.
You got 1.5? Okay. Because the 36 for red is 6, right?
wait.
Yes.
Yes.
So 40 over 6.666. You're doing that.
Divided
It would be 0.667, wouldn't it?
Yeah, 6. Okay, that's where I messed up. I just divided it by 6. So hold on. Divided.
Because I got 0.8999955.
Are we getting a negative number?
It
Yes.
should be negative. It should be
Okay.
negative. Let's see. 40 divided by.
Okay, well,
I'm not getting what you guys are getting.
in that case, I'm getting -0.8999.
That's what I got, Lacey.
Okay.
Let's see what I've got. I'm going to do so -6.
Okay, Michael got -0.9. So yeah, he got that too. Cool.
I still get -1 though. What am I doing wrong?
But the bottom part, when you divide 40 by 6, are you putting 6.667?
I go 6.666.
That's probably why.
Okay, let's try.
Because usually we round up 3 decimal places. So I went 6.667.
Yeah, but still, does it round up to 1 at all, you guys?
No, mine.
No.
Okay.
So then you would divide -6 divided by 6.667, and because the bottom number is higher, you would get something less than 1.
Okay, so we're dividing 40, right? By the square root of 36. So we're dividing 40 by 6, right?
Right.
6.
No, it's 40
Okay.
divided by 6.6667.
Okay. So let me try that. 40.
No, it's not. The square root of 36 is 6.
Oh, that's true.
Right. So it should be 40 divided by
40 divided by 6 is
It's
6.666.
point. That's right.
And then you got 6.66666, and then you take -6 and you divide it by 6.666, right?
Mm-hmm.
We divided it by 6.667.
All right. I get 0.9.
Okay, so since it's -0.899999, and we're supposed to round to the 3 decimals, would that mean that it's just -0.9 because it all bumps
I think so.
1 up? Okay,
That's our z-score.
yeah, -0.9. Okay, and then number 16, what is the p-value associated with the z-score from the previous question?
And we're looking for -0.9. And this is, the null hypothesis is what? Oh, it's that the p-value is less than 150.
Mm-hmm.
And then, so this is a left-tailed one.
Mm-hmm.
So we just need what's below that -0.9. So I get 4.1.
Because you're only shading the left part. Correct? Yeah, so
That's
0.1841 is what I get.
Okay, so it would be just 0.184.
I guess I should look at you guys every once in a while. Oh, he says, yeah. Just see what Michael's saying. Oh my gosh, it's brain surgery. All right, let's go. So what inference would you make?
Then number 17, I agree with Michael that it's failed to reject the null hypothesis.
Okay,
Yes.
so we have to compare it, right? Because what was our? Oh, alpha is 0.05.
Michael's saying because 0.1 minus 0.01 minus 0.1 is rejecting the null.
Mm-hmm.
Because the 0.184 is greater. It's greater than the alpha.
Yep.
So that means if the p-value is greater than we fail to reject.
He's saying 0.01 to 0.1 is rejecting null.
Okay, the p-value is greater, right? 0.184 is greater than the 0.05 alpha. Okay, I can't see him.
Correct, yes.
So that means we fail to reject?
Mm-hmm.
Correct.
Okay, sorry.
You're fine.
I might need my hearing checked. So we fail to reject because it's Because the p-value is greater
Mhm.
than alpha. Okay, sorry guys. I don't mean to be
You're
slow.
fine, you're fine.
So what is your conclusion for this problem? So we reject the null.
C,
We have insufficient evidence that the true population mean is less than 150. Because we have to reject the null, right? So that means that the mean is 150.
150 was the no, right?
I'm not going to reject that. So we have sufficient evidence that the true population mean is 150. We have sufficient evidence.
So we failed to reject, which means we have enough evidence. We failed.
But is that the same? We have insufficient
Does it
evidence.
say we have
D.
sufficient evidence that the true population is 150?
Yes,
Okay,
so B.
B. All right, number 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Okay, I have my little chart. So if the null hypothesis is true and you reject it,
Everybody has that?
what do you think? Yes, Michael? No, yeah.
Question 20.
Yes, please.
A researcher decided that instead of using a level of significance, alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
So, because that would be 1/10 instead of 1/20th.
I think it's the first one, the probability of a type 1 error will increase.
Yeah, that makes sense.
So that's 1 out of 100 or 1 out of 20. So you're thinking
Right.
the type 1 error
That
will
the type
increase.
1 error will increase.
Okay, Michael says A because 0.01 has a greater chance of the p-value being greater. Okay.
Okay.
21. If alpha equals 0.05, compute the probability of committing a type 1 error, round to 2 decimal places.
1 out of 20, so that's, what is that? What's 1 over 20?
Compute the probability.
Is that what it is? 0.05 is the probability?
Yes, yes.
Because if you take 1 and you divide by 20, you get 0.05.
Yes,
Is that right? Okay, guys, I'm scared to submit.
that's what I'm understanding.
Okay.
Yes.
Because it says right here, he didn't type anything.
We choose to be a small number so that the probability.
Well, because in the notes it says the most common value for alpha is alpha equals 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected.
Okay.
So it is 0.05.
0.05. Is it so?
Yes.
Is that's smaller, right, than the 0.1? No, that's bigger than 0.1.
That's smaller than 0.1.
0.01, I mean, because the
But
question we just
But
had.
it's bigger than 0.01 because 0.01 is 1 out of 100. This one's 5 out of 100.
Right, so is that a smaller chance then that the type 1 error will decrease? I was trying to wrap my brain around, sorry. Why don't we find out? Why don't we put this submit? Let's see what happens. I overthink things sometimes. This is my problem. Did we miss
Well,
one?
if the alpha value, the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be large. Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small. A level of significance of alpha equals 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus a type 2 error.
Hey, we got 20 wrong. I submitted mine. Did you guys submit yours? So 20 is wrong. So it's 18.
Okay, so is
So it's
18?
18. 20 and 18 are wrong.
Okay, so what is your conclusion for this problem?
Oh, the last one? Sorry.
Okay, wait, so that was just what I just read then.
Okay.
Okay, so as type 1 error decreases, type 2 error increases. So maybe
Correct.
probability should be that a type 2 error will increase.
Correct, because it's saying if the alpha value is very small, the probability of committing a type. Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small.
So, yep, so 18 is also wrong.
Okay, so where?
Everything else is wonderful.
Okay, 18. See, that's the one where I was like, So then if it's not that one, and you guys were saying there was sufficient evidence, then it'd be, we have sufficient evidence that the true population mean is less than 150. Correct?
So it would
I'm
be,
submitting. I changed those two, submitting.
Okay.
Okay. Nope. So
No,
I was right that number 18, there is insufficient evidence.
so which one is it, A or C?
I'm assuming that it's A, what I originally said, which was we have insufficient evidence that the true population mean is 150.
All right, and then was 20 right?
Everything else is right except for number 18.
Okay, so I will submit it.
So what did we get for 20?
For 20, it was the probability of a type 2 error will increase.
Oh, increase.
So
It's B.
18 is still wrong. It's C.
Wow. Okay. So it's less than, okay.
Boy, it's one thing to know, but figuring out, but it's another thing to understand it so you can do it again during an exam, for example. That's why I think we should take exams as a group.
I love that idea, because you know what? The more you talk through it, the more you can say, oh, yeah, that's why, and understand it.
All right, so did we figure them all out? I'm just writing down my answers as I go through it again, so I don't have to think about it. Anything else we got to do here? 21. Did somebody submit it and get 100? see. Just takes forever.
Okay, Michael got 100.
Okay.
So it's all okay?
Yep.
We got it figured out? Okay.
Michael, before we sign off, you didn't add my name for Tuesday's night. Did I attend?
I think you were there.
I can't even remember.
Tuesday night. Was that?
Yeah, it took us forever to go through that darn review.
That was the test review.
You were there, right?
Yeah.
Oh my goodness gracious. I'm so done this week. Okay, thank you, Michael. Sorry about that.
This was a bad week for me too. Much crying in the soup.
So is Colleen still part of our group or no? Or-
She just came once, right?
Yeah, she came once.
I'm assuming not.
Okay, well until she says something.
I would invite her, yeah. I would keep inviting her, but
Okay.
all right.
Or maybe I'll look if she's in a different group on the where we submit the group.
Did everybody get theirs submitted in?
Yep.
All right, I'm working
Yes,
on.
I can listen Tuesday.